Okay, I think it's time to get started. ITS lab, how many people there?
6.
6. Okay, and there is Ralph and Ayesha connected individually.
I have
So
Javed here with.
I'm going to stop the share over here and okay. So it must be 10 past 5 over there. Is that correct? Is it 10 past 5 over there?
Yes, sir.
Okay, we'll get started. So I have got a few slides to show, and I need to talk about your assessment, especially in regards to the research paper of which the proposal is due after 2 days. So hopefully all of you are working on the research paper and are all set up to give it a go. Okay. I have no idea what happened there. Can you still see me?
Yes, sir.
And can you still hear me?
Yes, sir.
Okay. All right. So I'm going to share the slides now. And I'm going to talk about the slides. So basically today's topic is on network management and mobility. And for today's major part of our class is going to be presented by the students, where I last week or the week before that I placed some research paper publications in journal articles on network management and mobility. And I told you students to prepare a PowerPoint presentation and share with you whatever you have read and whatever you have found from your own individual research. So we are going to look at that. But before we go there, I would like to highlight some of the things that I have. And oh, what is happening here? Oh, this is I'm at the end of the slide. Okay, now I'm at the beginning of the slide. I was at the end of the slide. So looking at last sessions, all of you please mute your mic unless you want to talk. At the moment, the ITS lab or the ICT conference room at Lodala campus, your mic is not mute. That is fine because you are in the lab. The rest of you, I'm not sure who the administrator is.
Hello, can you hear us, sir?
Yes, we can hear you.
So it's Shanika at
sometime I think we're not viewing your screen at the moment.
Oh, you cannot see my screen?
Not at the moment.
Hold on.
No.
Can you see my screen now?
Yes. Yes.
Okay, thank you for that. Please do, do chip in and tell me if you cannot see anything, because I have no idea of what you are able to view at your end. So it's all good. We'll continue. Any questions from the last lecture that we had?
No, sir.
Thank you. Last week we didn't have any tutorials. What we have done is we have combined the last week's tutorial, week 3, into week 4. Okay, so this is the week 4 of your course. You are almost 25% into the course. And today what you are going to present will contribute 2.5% towards your final marks. It is a combined tutorial 3, tutorial 4 combined. I'm going to talk about assignment 1 case study in the next slide. And once I finish talking about that, then I will ask you if you have any questions. Also, I'm going to talk about assignment 2 research paper in the next slide. And when I finish, I'm assuming that when I finish talking, I would have answered most of your questions. But if there are still any questions, please ask. Okay, so we are going to have classes during the mid-semester break. I think you guys at the moment are, the normal USP semester is in week 6. And you will continue until, let me check that paper. You will continue until week 7. And then from 25th August, you'll go on a mid-semester break. What we are going to do is during that 1 week break, we will continue to have the class again through Zoom. And with this type of, at the moment with this mode of lectures, tutorials, interactions, and whatever we are doing, we should have no excuses that you are traveling or you were unable to attend, or you had this, you had that, because this is a very flexible mode. We are not asking you to come to a confined space. What we are just requesting you to do is make yourself available and get yourself connected wherever you are on Tuesdays at 5 p.m. Fiji time. That's all. So I mean, I've been getting emails from students saying that they were traveling and they were away on a business trip. Come on. Are you a businessman or are you a student? So all these excuses don't seem, doesn't sound nice. I mean, it sounds too lame, to be honest. So please, try to commit yourself at least 2 hours in a week on a Tuesday at 5 p.m. Fiji time and get connected. And if you are having problem getting connected from day one, I have been telling you, come to the ITS lab on Laudala campus, or go to your postgraduate lab in Laudoka campus, and you will be provided with access. So I'm also going to speak about course requirements of an active student, as I have been exchanging emails with your head of school, and I have said that in IS433 information management, I have a number of inactive students, and what should I do, or what can I do? Because at the end of the day, these inactive students will spoil the results of my course. If they fail and if they get lower grades, and when I will present my results, it will reflect on my teaching, because if the students get low grades, that's a reflection on the lecturer. If students don't pass, again, that's a reflection on the lecturer. But the actual cause is that these students have not been active, they have not been participating, they have not been doing what they were supposed to be doing. So I've been told that I can remove and unenroll inactive students or penalize them in a number of things. So at the moment, I don't want to go there. I don't want to do that. I'll start hitting hard when I get there face to face. At the moment, online, remotely, let's go easy. I'm also going to talk about assessments in the next slides. Research paper proposals are due this Friday. I'm sure all of you are aware of that. And just yesterday, some of you were still trying to select a topic. And I'm thinking, when are you going to write the research proposal? Anyway, it is due Friday at 4 p.m. So I should receive your proposal emailed to me by then. Then we are going to look at this week's lecture activity that you are going to present using Zoom. I have sent out requesting for information from you students for to create a network, to create a research information network, because once I get back to Fiji, you guys will be the only people that I know. All the other that I know in Fiji are not there anymore. So that's why I always ask you to call me Sam, because I want to become your friend. Is there anything that the students would like to announce, or the students would like to say or comment on at the moment? Seems like there is none, so we'll move on. So, yeah, is there something?
Just wanted to inform you that we no more having class in ITS 14.
Yeah.
Having a conference room now.
Yeah. One of the reasons why you have been shifted to that ICT conference room is because ITS 14 does not have multimedia equipment, and the computers there do not have webcam and headphones, audio and all those things. And that is why it's been shifted to the ICT conference room, as they call it.
Just before coming to this class, I saw an announcement where it says that for Lodala students, it will be held at ITS 14. I think that might students.
Okay. And how far are you guys from ITS 14?
Just on the same floor, sir.
Same floor. So do you think there is a chances that some students are sitting there and...
Yeah, could be, but we're not sure.
Okay. Could be. What can we do? How long will it take for someone to go and take a peek in ITS 14 to see if anyone is there?
Just a minute or so, I guess.
Can someone do that, please?
Yes.
In the meantime, any other question? I mean, our normal venue is ITS 14, but just because today you will be presenting and you will need a webcam, you will need audio, you will need video, you will need to share your presentation. So that's when I requested Vinay to, my idea was to provide you with one PC like that in ITS 14, but they've shifted you out to ICT conference room, so that is fine as well. But in my next announcement, I will find out which room you guys will be in, and before I send you the lecture announcement message, I will include the room number. Thank you for bringing that up.
Thank you, sir.
Okay, was there anyone in ITS 14?
The person who went to check has not returned yet.
Oh, it's far away. Eh?
It's in the next building.
Yeah, but it's just on the same floor. He might be checking there in the class.
All right. When he comes back, you can respond.
Okay.
Okay. So to be an active student in this course, and as the course is being conducted online, and this is the future of education, one of the areas that I research on is educational technology. And I have attended a number of courses through MOOCs, that is massive open online courses. This is the future of education, because in time to come, students will not have time to commit themselves to 4-year bachelor's degree and 5-year courses and spend 6 years just attending classes. There is a possibility that they want to mix it up. And one of the reasons they want to mix it up is that by the time they finish the qualification, they would have that years of experience with them. For example, if straight after school you start working somewhere and also start studying online or through a technology like this or whatever we are doing. At the end of 5 years, because you are doing it part-time, you will get a bachelor's degree. Plus, with that bachelor's degree, you will add your 5 years experience. So a lot of people are going through that way. And nowadays, even people are selecting and nitpicking what they want to do within a degree, because nowadays a typical example is if you want to do a degree at USP, let's say Bachelor of Science in Computer Science and Information Systems, you are dictated to do certain courses which probably you don't like. So with this flexibility, you only choose the courses that you like, you only select and do the courses that interest you. So in short, there is no excuse for not attending this course. So we are in the 4th week of the course. If you have not done already, you must attend to the following immediately. Access the course materials and resources provided on the course module page. Select a research paper topic and submit a proposal. So if you have just woken up and realized that you are doing IS433 this semester, you have another 2.5 days to write a research proposal. Select a topic for assignment 1 and email the topic for me, XML prototype. On your course Moodle page, yesterday I have updated the research paper topics that have been taken and the XML prototype topics that have been taken. Most of you have selected a research paper topic. Only a few have selected the XML assignment 1, XML prototype. That is, what are you going to build your prototype on? So please, all of you attend to that and send me an email saying that you are going to do assignment 1 and develop a XML prototype for this particular topic. Attend online lectures from 5 p.m. on Tuesdays and participate in lecture activities and tutorials. So I've already emailed. If you have been inactive, you would have received an email, and the names of the students have been recorded, and this record also exists with the head of school. So if if this non-activity or what I would say complacent attitude continues from your side, then further action will be taken. I mean, if you are thinking that in the end, come week 10, week 11, 12, you are going to wrap everything up, complete assignment 1, complete assignment 2, and do whatever is required and finish the course, that is a good idea, but it doesn't really work. I have tried that. I've been a postgraduate student as well. I've tried that. It doesn't work very well. Okay. This is the next thing that is of concern at the moment.
Sorry to interrupt.
Yep.
In regards to assignment 1, I think we have a prototype, but I remember it's something about the case study, right?
Yep. Have I mixed the two courses?
Yeah, I think you have.
It's for IS413, I guess.
Oh my God.
For us, I think it's a case study.
Yeah, mix the two courses up, and see, this is what is happening. I'm getting bombarded by IS413 students and and IS433 students. So you guys are only no prototype, but just a case study.
Yes.
Yes.
Sorry about that. Where? Yeah. Thank you for that clarification. So yeah, that brings us to the new point. At the moment, the first thing you do is send emails to me directly, and those that have sent emails to me directly would have noticed that I reply within an hour, or sometimes I reply immediately. Please, please include the name of your course as the first word of the subject of your email to me, because students are sending me emails. I want this topic, I want that topic, and I want to do this, I want to do that, and I have no idea which course you are attending. I must have told you before that this semester I am teaching IS433 on Tuesdays and IS413 on Thursdays. Both of my courses have same assessments. Both of your second assignments are research papers and also on the same topic. Mostly similar topics. And one of the reasons why they are mostly similar topics is because all these topics are my current areas of research, and so I feel qualified enough to be able to guide you on the research paper. There are some topics that I'm not very familiar with, but by the time I would have read enough and caught up with those topics. And so please use the course code as the first word of your subject, and then your subject, the rest of the subject should be descriptive about the content of your email. And I have decided that if you do not comply with these requirements, you will not get a response from me, because I end up exchanging like 5-6 emails with a student trying to find out which course he or she is doing. And that wastes a lot of time. You guys are IT students, IS students. You are the last people on earth I should be telling about email etiquette or how to email and what to include and what not to include. Do not send me messages through your course Moodle page. These messages will not be answered. Sorry, I'm getting a bit nasty, but that's what happens when you start getting overwhelmed. Avoid asking anything that has already been specified. For example, it has already been specified that you are going to do this assignment in pairs. Do not ask me if you can do it individually or if you can do it in groups of 3. And please read the resources that has been provided. Some of the students that have just woken up and realized that they are not doing, that they are doing IS433 this semester are sending me emails selecting topics that has already been taken. Okay, so that doesn't look good. That doesn't look professional. All right, any questions in regards to this slide?
All good, sir.
All right, thank you. Next, I'm going to talk about the research paper assessment. So either you do it individually or you do it in pairs, not groups of 3, not groups of 4. Research topic, once you have selected, send me an email, and you have seen that I have standard replies to your emails on regards to selection of topics. Research proposal is due this Friday, 4 p.m., and you are going to email it to me. The proposal should be formatted Times New Roman, 12-point font, single spaced, minimum 2 pages, maximum 4 pages. This was a question asked by a number of students. The proposal needs to have, the proposal needs to use or have 10 journal articles reference. Needs to use or have. Okay. And you must use a hypothesis or a theory or a model framework to validate your research findings and compare your research with others. I'm going to talk more about this, and then I will let you ask some questions. So, hypotheses, theories, models, and frameworks, why do we have to use them? It is simply to validate our research findings. There have been a number of hypotheses. Hypothesis is very simple and very easy to execute. So most research papers answering hypothetical questions, most editors do not regard them as very quality articles, very quality questions, because their paper just answers a question, yes or no, or proves or disproves the hypothesis. However, research papers that use theories, models, theoretical frameworks, and conceptual frameworks to test their research findings and to validate it against these established theories, models, and frameworks are deemed to be very good research articles, very good research papers. You know, if you are doing science like biology, physics, chemistry, or computer science, your research is very easy. You just run experiments, execute computer algorithms, write computer programs, do simulations, look at the output, look at the results, do some observations, and bam, your paper is done. But for us, on the information system side and on the topics that we have, we tend to align towards the social science research paradigm. And at the moment, I mean, most of these topics can come under computer science. Most of the topics that we are looking at can come under computer science, but we are not at that level to be going, and we do not have the time and scope to be going and setting up things in the lab and running experiments or developing and executing and then writing about it. So we align towards social science research methods to complete the research paper for this course. So this is what I'm going to suggest. Once you have selected your topic, maybe this slide is a bit too late, and if need be, I can extend your research proposal by a week if you are struggling, but
Yes,
if you've
please.
already done that, then it's good. Once you have selected your topic, you have to decide what type of data you are going to collect and how you are going to collect that. Most people, I mean, most students that do not have time or that are not involved or that are not based in a lab, what they do is we call desktop research. Desktop research is using your desktop computers, laptop computers, finding articles, reading articles, and then deciding what you can do with this desktop research. So once you have decided what type of data you are going to collect and how, some of you have already indicated that you are going to base it on your organization, or you are going to base it on the work that you are doing. So that's fine. That's really good. So if you are going to collect text data, again, from desktop research in terms of published papers and journal articles, you are going to use a qualitative research method. And if your research is going to collect numerical data, again, this could be in terms of the number of papers. You can collect the text data, the number of papers that are talking about the privacy of cloud computing, the security of cloud computing. You can enumerate them and use quantitative methods or a mixture of both. So once you have done step numbers 1, step numbers 2, then you can apply or use a hypothesis, apply a theory, model, theoretical, or conceptual frameworks based on the above 2 steps. For example, if you have taken up topics like e-commerce or e-business in Fiji, or you want to look at how people are the users in Fiji keen to perform transactions, keen to take on e-business, perform e-commerce and things like that, then you can use a technology acceptance model, or UTOD, the universal theory of acceptance and use of technology. So how will you know which theory, which model, which theoretical framework or conceptual framework to use? This will be based on your literature review. So for literature review, once you have selected a topic, you will decide, okay, I want to do this. Let's see if anyone else has done that. If anyone else has done that, it's good news for you, because you already know that they have done it and they have published this. So this research is validated. I mean, people are interested in this. And look at the citations of the paper. That will also give you an indication of its acceptance. And once you have decided, so you can replicate their research, which means you can use the research instruments, you can use the research methods, but the only difference is you are collecting data from a different place. So what results you get, you can compare it, do a comparative analysis against what they have got, or you might get something different and you can write on that. So in research, rule number A is, or the rule of the thumb is, do not reinvent the wheel. If something has been done and if something works, use it, replicate it, make it easier for yourself. If you don't want, then you customize it, you change it, you tailor it to your situation, to whatever you are doing. Okay, one more slide, and then I'll give 3 minutes break, because in 3 minutes I'm going to get some water, and then I'll entertain your questions. So I'm going to leave this slide here. You can take a look, and I'm going to take 2 minutes break. When I come back, I'll be ready for questions. Okay, questions?
Sir, we were searching for some research papers or journal articles online for our research.
Yeah.
Some of the papers are from IEEE or somewhere where we have to purchase it.
Okay.
And those are the good ones. So is there any
I
way
know.
you can help us out in that?
Good papers are all for sale. The crappy ones are free.
Yeah,
Okay.
exactly.
I'm of the understanding that USP subscribes to a number of databases, and through USP library you can search.
Yeah, we do have ProQuest and all. Yeah,
That's it. Apart from ProQuest, anything else?
Jason, is it? Yeah, few others as well.
Okay. So if you come across a paper that you really think that will be good and you cannot access it, you email that paper, email the name of the paper and authors to me.
Okay,
I'll try to access it from my Victoria University of Wellington's library.
okay,
And if I'm able to access it, I'll send it to you.
okay. Thank you so much.
Anyone else? Any other question? So can I know how many students are in the ICT conference room now?
6 of us here.
6. And then individually there is Aisha, Rajneet, Ralph, Sharika. 1, 2, 3, 4. 10 students.
I have Javed with me here.
Javed, I cannot see you.
No, he's with me.
Who?
Ralph.
Oh, Ralph and Javed together. So that makes it 11. Okay. All right. So let me finish the slides and then it will be over to you guys. No other question?
All good, sir.
All right. Okay. So who's this talking to me?
This is Jessica.
Jessica. All right. Okay. So this is the format of your research paper proposal. Let's look at the case study, report and presentation. So you have to identify a key area in information management. You can choose any area, it's your own choice, and you will present that in class. You will work as a team of 2. No 2 groups should do the case study on the same topic, and that is why I am recording and providing to you the topics that have been selected. However, the topics are very broad, and I do not see that any two groups, or any group, will end up picking the same case study. However, you have to email it to me as soon as possible, and I've already provided resources on writing a case study and doing a case study analysis. So, any questions in regards to that?
All good, sir.
All right. So, course materials and resources on Moodle. Now I'm going to share your course Moodle page. This is the one. Can you see this page? Can you see the course Moodle page? No?
Yes, sir.
You can? Okay. So nothing much, everything is the same, but you will see that on a regular basis, just like this was updated yesterday at around 2 p.m. This was also updated yesterday at around 2 p.m. Okay, yeah, I had to I have to take it to student view, sorry. Okay, right. And we have already talked about these two documents about your case studies and these two documents about your research paper writing. And if you want to have a recap of the lecture, this lecture has been recorded. Doesn't seem like. Hold on. Oh yeah, it is being recorded. And this was the lecture activity. So after at the end of the lecture, I'm going to put these PowerPoint slides back there again. Right, moving on. Okay, I've already talked to you about this. Do send me those information. And I have some slides on network management and mobility, but what I would do is I will stop here and let you present whatever you have got. And if there's still time left, then I'll go over the slides. Otherwise, I will upload this on Moodle and you can go through it. Right, so who wants to go first?
I'll go first. Reginald.
What's your name?
Reginald.
Reginald? All right, go ahead. So everyone, by now you should be able to see what I'm doing. So you go down, you click on share, and you share your PowerPoint presentation. And at the end of today's lecture, please do send your presentations to me. And what else you do is you enable your audio and you enable your video. Reginald, you're good to go. You are in the ITS lab today, Reginald?
Yes, sir.
Okay.
Which one? We are in the video conference room.
Okay. Yeah, yeah, good. Go ahead.
So you need to stop your share screen so they can share the screen from this end.
Share my.
Share screen, right?
No, go again. It's there. Can you guys connect it from your?
We can see your PowerPoint slide,
Yeah, thank you.
Reginald, but we cannot see you. We can hear you. We cannot see you.
That's me at the workstation.
You are in the ICT room?
Yes. Today I'm here. Not home.
There should be a computer with a webcam.
No, I'm in the conference room today. I traveled to USP.
So you guys are attending from two different places?
No, I'm together with the other students in the video conference room.
So in the video conference room, there will be a computer with a webcam.
Sir, we're in the USP ICT conference that you see right on top.
Yeah, yeah.
Officers are sitting here.
And there's no computer with a webcam?
There's a computer, but I'm facing the same camera that all the students are facing. There's only one camera.
So the presentation is from the computer in this room, the ICT conference room.
Okay, I'm getting confused. What's going on?
The presentation that I'm showing is from the ICT conference room where everyone else is based.
Okay. And there is no computer with a webcam over there.
I'm using the camera that is in the conference room.
And the camera is focused on all the students.
Yes.
That's why I cannot see you.
Yes.
Okay, got it. Go ahead. Sorry about that.
There I am.
Hold on. Because at the moment I can see your screen. Hold on. Yes. Is that you? Are you sitting down?
For now.
Yes, I can see you. Wearing a black jacket or something.
And if I stand up, you can't see me now.
No, sit down. Must be really cold in Fiji.
I'm a bit sick as well.
Okay.
Yeah,
Go
it's
ahead.
really cold here as well.
All right. Go ahead, please.
Thank you. Good afternoon, everyone. My name is Reginald Gunny. I'd be presenting on edge paradigms, and my presentation is based on mobile edge computing. Fogg et al. On the document that I used is on the top left hand of the screen. Now, my presentation focuses mostly on these areas. All of us are familiar with the internet. We've talked about the cloud a lot in the past courses that we have done, and if you are new, I'm sure you're already aware of what the cloud is. But cloud has expanded. More paradigms have come through the use of cloud. The three areas that we are going to talk about today is fog computing, mobile edge computing, and mobile cloud computing. These activities are so prominent that they are now paradigms on their own. The first activity is called fog. The first paradigm is called fog computing. Sometimes it is interchangeably used with edge computing. Over here, cloud services will be deployed at the edge of the network so that they can be deployed in other locations. All right. So this is essentially on the edge of your network, from the cloud right on top to the edge. These guys are somewhere in the middle towards the edge, actually. Sorry. Mostly this has to deal with Internet of Things. Now, when we talk about edge computing, we talk about Internet of Things, meaning that we talk about any device that is connected to the internet: cars, games, street lights, traffic lights, any technology whatsoever. Now, if we have to conceptualize that, that is how we would represent fog computing. The data center or the cloud right on top, fog nodes in the middle, and edge devices. With cloud, you must understand that all data travels to cloud. Every single bit of information goes into the cloud, gets analyzed and processed. With fog computing, there's somewhat a bit different, whereby some processing will be done in the fog nodes, and the entire stream of data that is going to travel to the cloud is not going to be just dumb information that is traveling to the cloud. It will be a bit analyzed, a bit processed, and the concrete information that travels to the cloud will be used to make a further analysis. Just to differentiate between fog and conventional cloud, this simple chart is good enough to explain to all of us. This was taken from an article by T.H. Luan on fog computing. The core target users, or the target users for each of these concepts, are different. With cloud computing, we use general internet users, involves basically all devices, especially PCs and desktops. Whereas fog computing emerged with the dominance of mobile computing, and cloud computing, of course, is global. Whereas in fog computing, we have to localize it to the certain areas where we are going to deploy them, and we cannot go into depth right now because of time limitations. So I'll just move to the next slide. Then the next slide talks on mobile edge computing. It aims to provide an IT service environment and cloud computing capabilities at the edge of the mobile network. Over here, they can offload their tasks to resource-rich computers and clusters. Mobile edge computing provides IT and cloud computing capabilities within the radio access network in close proximity to mobile subscribers. So over here, this is a bit further away from fog, more closer to the devices that are being used by the different people that are going to utilize the technologies. For this to happen, you must make sure that there are resource-rich clusters where these mobile edge computing devices will be able to offload their resources to. In this sense that these mobile devices do not have enough resources to process the information that is currently being gathered. There is a simple diagram demonstrating what mobile edge computing is. There's the cloud on the right-hand side, and then there's the mobile device on the left-hand side, and then we have got these clusters of resource-rich machines where processing will take place. So the mobile will dump information to the cluster using the Wi-Fi device, Wi-Fi technology and the wireless technologies, and these clusters will upload the relevant information after analysis. The third one is called mobile cloud computing. This is actually a predecessor to the others, and this is what fog computing and mobile edge computing well actually sprung off, if my reading serves me correct. Mainly focuses on the notion of mobile delegation. Due to the limited resources available on mobile devices and the storage and the execution of computationally intensive tasks to remote entities. So from mobile devices, we were able to transfer information data to cloud devices so that some form of processing could happen. This is how we use cloud with our mobiles. Actually, we just collect data. If we are going, for example, if you use, say for example, an application of cloud, this is how it's going to happen. We use email, we use Word Online, Google Labs. All this is based on mobile cloud computing technology. And thank you. That is the end of the presentation. These are the resources.
Thank you, Reginald. Well done.
Thank you, sir.
Next one, please. Who wants to go next?
Me. Shavinder here.
Who is that, me?
Hang on, let me just do the presentation, please. Can you see me, sir?
Yeah.
Right. Hello, everyone. It's Shavinder here. You can call me Shavin. Sorry, I'm not really good at presentation, so please bear with me. You guys can see my screen, the people who are connected outside this ICT.
Can I know your name, please?
Shavinder.
Shavinder. Okay, yeah. Shavinder, the reason why we are doing this presentation is because we know you don't like doing presentations.
Okay. Okay, so today's presentation is on network management and mobility. So before I start off, I'd like to brief you guys on what network management and mobility means to the users or people. So as I've noted there, the process of implementing and managing computer networks and services provided by the screen include fault analysis, performance management, provisioning of networks, and maintaining the wireless service. And mobility is the flexibility. We all knew when it comes to mobility, we all know the word mobile. Mobile is not the mobile we use, but the flexibility of the network that we all want in today's world, right? So without wasting much time, I'll move forward. All right. Before I go to the note section, I'd like all of you to have a glance through this image that I have included in my slide. Basically, this is the evolution of the generation networks from where 1G was introduced, and now we are into the fourth generation. All right. You can see here I have noted this picture says the speed of the network that is generally increasing, and that is what we are all after, right? They says every aspect of the enterprise depends on connectivity, and almost everyone wants mobility. At work and in our personal lives, we need or expect immediate network connectivity to text, tweet, social media, database, news, apps, and everything else. It's like if you want to watch a YouTube video, we don't like pausing and waiting for it to download. We want to click on it and just play, right? If you want to scroll to your newsfeed on your Facebook, we don't want it to keep on connecting, right? So I don't think you guys must be aware. Recently, there was a 4G WiMAX network that was implemented in Mexico, right? That was basically for the railway industry, and what it did was to get the users, attract the people more into the train services and connecting all their railway services and through the WiMAX tower that they had, right? So if you look at this picture here, we are on 4G right now, and what matters is the data rate, right? That's what we are going to look at. That's what we mean the mobility of the network, how fast the data can travel, right? So at the moment we are experiencing 100 megabits per second. So basically, if you want to know what size of data can be transferred from one place to another, you probably just divide it by 10, right? That will be 10 megabits per second, right? That's the current technology, network technology that we are using. However, that's not enough, and we are not really satisfied of this, right? So as I have noted here, you can see my screen, sir? Hello?
Yes, I can see your screen.
Right, I have noted here that due to the increase of the number of people who subscribe, I think in the previous lecture you gave us an example of people using WhatsApp in India, saying some good morning and stuff, and how much the data that is being used, right? So in that context, if you see, then that means 4G is not enough. It's not reliable. If it's not mobile, it's not what we want, right? So what next are we going to experience in this world, right? What next is coming to us? So if you see the image that I provided is from one of the articles that was provided by you. This is
Yeah,
a
okay.
structure of a 5G wireless network,
Mm.
right? So and that's what we see as a potential 5G wireless, right? Before I read on this, I think I don't think people or you must be aware that I think it was last year November sometime Vodafone PG they introduced 5G wireless trials in PG, where they managed to did a successful test of 1 gigabits per second, right? So basically, the 4G is running on 100 megabits per second, right? So the 5G wireless they have tested to have 1 gigabits per second. That means you can download 100 MB per second, right? So the trial was successful in Fiji. So we are hoping of the implementation by around 2020, right? So as I have noted in the notes, this is from the article. It's to achieve or to meet the 5G requirements, we need a dramatic change in the design of the cellular architecture, similar to this concept that was specified, right? The design of the wireless system should take account minimizing the energy consumption, right? in order to achieve green, basically what we are talking about is the number of antennas, that will be used for these wireless technologies will be generally increased, right? That's what the MIMO systems are saying, massive input and massive output systems that will be implemented or that will be brought in place in order to achieve the 5G wireless systems, where we will increase the data network rate to 1 gigabits per second, right? However, to achieve this, we will have some challenges which I'm going to discuss in the next slide. All right. It says to attain the 5G wireless network, we will need to optimize the performance metrics, right? And these include the energy efficiency, delay, reliability, fairness of users, right? Implementation complexity, and so on, right? So a general framework should be developed to evaluate the performance of 5G. Also, adding on to that, I have written about reducing signal processing complexity, right? Basically, you have seen I have put this word here, SM, that's basically talking about spatial modulity, right? So what it's going to do is, instead of simultaneously transmitting the multiple streams from the available antennas, it will encode part of the data to be transmitted onto the position of each antenna, and probably what it will do, it will keep one antenna active at one time, and the rest will be idle. I'm talking about these antennas. This is a structure of a 5G wireless, right? So that's how we'll be able to achieve the wireless system with the massive input and output, which will be done through the increasing number of antennas. Okay, and that's it.
Is ours on or off?
Thank you, Shavinder. Who wants to go next?
Okay, can I present?
Yeah, go ahead.
Okay, thank you, sir. Say there's a message, you cannot start screen share while the other participant is sharing.
Yeah. Shavinder, stop your share. Okay.
Yeah, it was disabled still. Sarika, can you try it now?
I tried now, okay. Let's see, selecting the application. Okay, yes, I can. Okay. Good afternoon, all.
Good afternoon.
Okay.
Sharika, we cannot see you.
Okay, say. Okay, start video. Say,
Yeah, we can see you now.
Okay,
yes.
sir. So the topic that I have selected for my activity is on 5G wireless communication system, and that's on cellular architecture and key technologies for 5G wireless communication networks. Basically, wireless communication systems is
Sarika, you have to open your PowerPoint and share that PowerPoint.
Okay.
Are you using dual screen?
Wait, let me. No. New share. Say, I'm trying to.
Are you using dual screen, Sharika?
Dual screen. No. Okay. It says I did get my share IDs here.
Yeah, no. Your screen is shared, but you haven't opened. You haven't opened the screen is shared, but you haven't opened your PowerPoint. You've just selected it. We can see your screen.
Okay.
You can see everything on your screen, all your files. It's good you don't have any secret files there.
Okay, so I'll try again later. Somebody else can continue.
Okay. All right.
I have Javed here with me, Dr. Gaundra. Can we start next?
Can go next.
Sharika, can you uncheck our settings?
Okay.
No, I'll share it for you.
Good evening, everybody. Good evening, Sam.
Javed, we cannot see you.
Just working on it.
Sorry, we can't share screen either.
Disable the screen. Who's this copying the presentation?
Ralph.
Okay.
The other one, no, the other, hello, Jessica. The other account, Ponrom_R.
So it's not you doing it, right?
No.
Do you have a control over?
Someone has taken control?
Seems like someone from the ITS. Can you try it now?
Students in the ICT conference room, please go back to your computer and release control.
Yeah, just a minute.
And unshare and exit.
That's yes.
Yeah, Ralph, you are in control.
Okay, you can see. Can you see the screen?
Can you see the screen?
Yes.
Yes, we can see the screen.
Okay. How do they see me?
Yeah, I'll see you. Okay, there. Can they see you?
I think it's backward.
Oh, sorry. Set.
And
Okay.
we can see you, Javed.
Okay.
Not
Good.
anymore.
Oh, sorry. Sorry, it's connect. Something's wrong with our camera.
Yeah, we can see you.
Oh, yeah.
You can see me?
Yes.
Okay. Continue.
Okay. Good evening, everybody. So my name is Javed, and I'll be discussing the lecture 4 on network management and mobility. So as you can see from the slide, next slide. Basically, when you talk about mobility, I think one of the first things that came to my mind was cloud computing. And cloud computing is anything that is a collection of computing resources, example, network, servers, storage. These are all pooled to serve multiple consumers using a multi-tenant model. I've pasted an image over there. I hope you all can see it. It shows basically the users such as those who are using smartphones, laptops, anybody who's wearing a wearable device, or if you are into smart vehicles. I don't think there's any in Fiji, but mostly in overseas. So all of these are connected to a cloud. I think some of the ones we are familiar with is the Google Drive, Dropbox, which we use here in USP as well, OneDrive, very common, and Oracle as well. Oracle, recently Vodafone, in fact, launched something known as Oracle Cloud Solutions. I have been following up on that one, and they're planning to do something big with it. I think that's why the whole logo is the future is exciting, ready, and I think that's where we're moving on right now. Next slide. The second slide basically is dealing with the ICT and innovation in ICT. When we are going on to cloud, it's creating a lot of data, so we're trying to become independent from hardware devices such as our storage devices, and so everything is now on the cloud. But in order to access everything properly and in time, we need to actually be able to do it with the proper internet connection. And while 4G is really fast, I think it has proven a bit of challenge, especially when it has to be passed out through a thick wall or bricks or anything. So I think the next stage in evolution is the 5G network. With 5G and cloud computing, I think we will all be able to access documents, videos, movies, everything on cloud. And everything will be done more easily. Instead of buying softwares, everything will be, the entire account of a person, I think, will be on cloud storage. And I think that is something that's really exciting. So while those were the aspects of mobility for me, mostly cloud, I think the other aspect is uh, network management. And speaking of network management, apart from mobility, there are other factors that make up business networks. And these are collaboration, relationship, and search. If you look at collaboration, it talks about working as a team or with others, with members having access to and sharing documents or other types of files. When you talk about relationships, it's maintaining contact or interaction with customers, supply chains, stakeholders, even it can be university students, employees, etc. Search is looking for and finding data. I think we have a lot of data these days where in fact there's a lot of data, there's a lot of information, but there's, I think, lack of knowledge right now, which we are really drowning in data and information, but the knowledge is lacking. So that is something that we really have to go through. Just quickly, enterprises are moving away from unsystematic adoption of mobile devices and infrastructure to a strategic build out of mobile capabilities. Factors that are actually contributing to mobility include the following: new wireless technologies and standards, high speed wireless networks, multitasking mobile devices, more robust mobile operating systems and applications, increased competitive pressure as others start adopting mobile technology, overall increased speed of business. These are some of the actual factors that are contributing to mobility. And if you look at the next slide, it's basically just an image which just shows how the entire Wi-Fi network and WiMAX, they all work together. So anything that has a built-in WiMAX adapter, whether it's a laptop, mobile phone, desktop, any other device such as a smart wearable device, they can basically access the WiMAX network and the WiMAX hub, which connects us to the Wi-Fi hotspots. Hotspots, it can be in buildings, it can be in parks, as you can see, and these all interrelate and provide us with a set of information that otherwise would not be easier to access on a landline or a LAN connection. And yeah, I think that's all from my side. Thank you. You go next. Ralph will go next.
Go ahead, Ralph.
Hold on. Wait. Is my screen on shared, Jessica?
Yes. We can see you, but not the slides.
Okay.
ICT conference room is in control. Ralph, we can see your screen as well. Now you've completely gone off. Anyone else in the meantime while they connect again?
Yeah, Rashna here.
Yeah, who's next?
Nah.
Good afternoon. Can you guys hear and see me?
We can hear you. Can we know who you are?
My name is Rashna Lingam, and I'm one of your students here. And
Okay, and Rashna, you are in the ICT lab?
yes, I'm in the ICT lab with the other students.
Okay, we cannot see you.
Sure. Okay, let me see if something can be done about it. Where's the other one? This Internet Explorer. Okay. Yeah, I can do that.
Rashna, we can see that you are about to open something,
Can you
but we cannot see anything else.
see me now?
Yes, we can see someone sitting there.
Me. And can you see my slide?
No, you haven't opened it yet. You have to open it and you have to share it.
Oh, it's paused. Sorry, it was paused. Okay, can you see it now?
No, you haven't shared it yet. We can see the folder that is there called IS433. Yes, we can see your slides, but we cannot see you.
Change. The video is on. Students can.
Yeah. Okay, continue, please.
Can we? It's on. So is it on now?
Rashna, continue, please.
Okay. Oh, you can see my slides, right?
Yes, we can.
Okay. So, good afternoon, everyone. I did my research and reading on the paper that's mobile edge computing and
It's on now. Oh,
analysis of its threats and challenges. So I will talk about what is edge computing, what is the purpose of edge computing, and what are the threats associated with it. So with edge computing is a component that has come through cloud computing. Cloud computing is basically hosting your files and computer operations, all the technologies over a platform that is connected via internet. For example, Google Docs. We have Gmail accounts provided by USB. We have the Google Drive. In that we have the Google Docs. We can put in any information or use those services which are automatically updated. You don't have to really wait for things to take process. It does not take a lot of time to process. It's instant, right? In Fiji, we have Vodafone, which is one of the major telecom providers who are using cloud platforms to enhance their services and technology. So on this side, you can see a picture of how they are using cloud to incorporate in their business. And the latest news, they have released they've released that they'll be creating cloud data centers which could be used by the businesses to host their own services. This was this last one. Okay, so edge computing is coming about because there are a few limitations with cloud computing. So one of the limitations is centralization. With cloud, we have a device and the cloud server could be hosted in a central location that could be very far from the individual users. For example, if I'm using my mobile phone and if I go to Nandi and I try to look for the nearest restaurant, it's very instant now. You just go on Google, on your phone, Google, and you can get the nearest restaurant. But with cloud computing, because there is a variance or there is a lot of distance between the user and the cloud server, there were network slow, there was latency, jitter, and there was bandwidth bottleneck. And with edge, you can also support mobility. So when we say edge, we have the cloud on the very top. We have a a terminal in the middle that could be a fog or a mobile edge computing server. I'll show you in the later slides. So the key thing was with clouds, it was centralized and it has barriers with locations which caused slow transmissions. With that came in the edge computing technology. Edge computing is decentralized model that allows data computing, storage and services to move from cloud to local edges, right? One of the examples is the smartphones. So if you look at the smartphone, when we began with smartphone, we had a device with a long aerial kind of thing, which you need to actually put, amend to communicate. Then it went down to a smaller aerial, and then we had keypads, and now keypads are gone. We have smartphones. So with smartphones, a smartphone has the IP, a smartphone has the internet, and it has processors. It allows users to do things instantly. You can take a picture from your smartphone and upload it on Facebook via the app you have on your mobile. So those capabilities are through edge computing, and the three technologies we have are fog computing, mobile edge computing, and mobile cloud computing. So fog computing is basically bringing the cloud closer to the user, as I said, with devices on the network. So if you see a diagram here at the bottom, the edge is the fog, mobile, and mobile cloud computing. Fog uses a fog node. These are the devices on the network. These are your laptops, your mobile phones, which can operate within it. As I said, example of Facebook. And one of the real life examples we have is the connected car that will be introduced by Tesla that have internet on the cars. Even we have smart cities where traffic lights are using internet to navigate the directions. With mobile edge computing, the cloud services are deployed with the help of a mobile network, for example, 5G. In case of 3G, we have the Vodafone's vehicle tracking system. They are communicating with their network centers with the satellites through cloud. With the mobile cloud computing, you are sending data from your mobile to cloud, and this is through the wireless, and that uses the cloudness. So these cloudness are small, I would say, servers that allow you to communicate with the cloud, right? With these enhancing technologies, there are some challenges and threats. So if you can see, the challenges and threats discussed in the paper are associated with their key components, or I would say the assets that are used in the setup of edge computing, the infrastructure, what equipment has been used to set up the edge computing. Edge data center is basically the center where the edge computing servers are hosted. And then the virtualization infrastructure is used by mostly mobile edge computing. These are virtual servers that are used for the transmission and interchange of data. And then again, it's us, the user devices. So most of the challenges that was highlighted in the reading was that there was a challenge of actually implementing the edge computing technology because it's decentralized. We need to host it in different locations. For that, we need abundant supply of materials. We need skillful resources or individuals to do the implementation, to monitor the setup and to ensure that it's up and running. And then we had to ensure that it's mobile. It could be accessible by any device at any location and time in real time. And the threats were again associated with the mentioned assets was denial of service. We could have attackers on the network who could jam the traffic, minimizing the transmission rate. Privacy, we could have people getting into the systems, unauthorized users getting into the system, blocking the network, or leaking in critical information, because remember, as Reginald said, edge computing is all about Internet of Things. Internet of Things, every person in this modern world is connected on the internet. We are here on the internet. Students are on their from laptops, phones, smart TVs, even from smart cars, as I mentioned. And the other threat mentioned was us users. We could have access to some other person's phone. We can inject information. We have so many cases of Facebook hacking or email hacking accounts and spam emails. So those are some of the threats and challenges associated with edge computing. And that's my reference. Thanks.
Thank you, Rashna. Who's going next?
Jessica.
Right, Jessica.
So who's going next? Jessica. Oh, okay.
Okay. Where? Scroll over here. The file is open there. IS4 percentage here. Green. D percentage here. Is it shared? To where?
Yeah, can't hear you.
Yeah. Can you see my slide?
We cannot see your slides, Jessica. We can see you, so you'll have to share your slides.
Just a minute. Share slide. Can you see it now?
We can see your slides and we can see you. Please go ahead.
Okay. Hello everyone. I am Jessica Salanki, and today I will be presenting on information management. Sorry, that's our course. So my focus for this week's lecture is network management and mobility. So before I start off, I would like to take you on the learning objective. So what are we going to cover is what is network management and mobility. It is very important for us to know what it means. And then we will be discussing on mobile and wireless communications, evolution of wireless communications. This is where we will talk about 1G, 2G, 3G, 4G, and how we are now approaching to 5G. And this is where we will talk about why there is a need of 5G and the approved 5G architecture. So here it shows this picture. So this and this talks about the network management, and this is something that adds up to is the mobility. So network devices that communicate with a network. So whenever the word comes network management, we always have to think of network devices. So can anyone over here tell me what are some of the network devices that we deals with? Right, so we deals with switch, routers, modems, all that we use, right? Computers itself, without that, how can it be possible? So all that. So, and what does this network devices allows us to do? It allows us to rapidly collect, process, and share data acted upon for a competitive survival and advantage taking. And so network management itself is the process of administrating and managing computer networks. So services provided by this discipline includes fault analysis, performance management, processing, provisioning of networks, and maintaining the quality of services. Now let us highlight a bit on mobility itself. So as my friend has already discussed what mobility is, so it is about mobile. Everything is in our hand, right? So it is a secure, reliable access from anywhere at an acceptable speed. Right. So mobility management networks, it is now supporting cities to effectively improve their integration across transit modes make public transport more attractive and easier to use. So further on, today we will be discussing on one such network that is rapidly being used, and that is mobile wireless communication network. So mobile, we all are aware of mobile wireless communication network. So in that, it says that mobile and the wireless communication applications, they have a clear impact on improving the humanity well-being, from cell phones to wireless internet to home and office devices. Most of the applications are now converted from wired into wireless communications. And smart and advanced wireless communication environment represents the future technologies and evolutionary development step in homes, hospitals, industries, and transport systems. So with that, it gives rise to the evaluation of mobile communications. So this diagram over here, it shows how we have move up from 1G towards 5G, which is in future that we will looking forward to. So in here, each generation, they have some standards that they follow, right? And they have the different capabilities and new techniques and new features which differentiates from each other. And there is the reason why they exist. And that's why we had to bring in from 1G to 2G and 3G, so forth. So 1G over here, it is analog and it only applies for the voice, like it only transfer that. So that is back then, right, when there was a struggle. Then we have second generation, which was in 1990, and it has mobility roaming. So it is a digital technology and it supports text messages. And then we had this in between 2.5. And then we had third generation, which was out in 2003, which has multimedia, and that is like it's a mobile technology which provided higher data transmission rates. It has increased capacity and provide multimedia support. So that's an advancement from 2G. And in here, 4G, this is what we claim that we have. And that's a full IP, right? So it is integration from 3G with a fixed internet to support wireless mobile internet, which is an evolution to mobile technology, and it overcomes the limitations of 3G. And it also increases bandwidth and reduces the cost of resources. And now that since we still have some challenges with 4G, so we are now moving on to 5G. And it is going to be, that's what they claim, that it is going to be a new revolution in mobile market, which has changed the mean to use cell phones within very high bandwidth. So that's that. So now let us see why there is a need of 5G. And in here, I will be discussing, reflecting on the paper that is Cellular Architecture and Key Technologies for 5G Wireless Communication Networks. So in that paper, the writer claims that there are challenges that cannot be accommodated by 4G. In here, we have, most of us use Vodafone, and we're still having problems with 4G. You might agree, you might not, but well, I have it. In some areas, we still go to 3G, and we still have that problem of transferring our messages or our data or whatever it is. So just as my friend mentioned that sometime Vodafone has launched 5G and they practiced it, and they're claiming that it will be out and about in 2020. But let us see, because Fiji is still struggling with 4G up to that par. Okay, so in that paper, they have discussed about these challenges that still exist with 4G, and that is the scarcity of radio frequency spectra, So it is allocated for the cellular communications. Cellular frequency uses ultra high frequency bands for cellular phones, normally ranging from several hundred megahertz to several gigahertz. And then there is a deployment of advanced wireless technologies that comes at the cost of high energy consumptions. Then we have average spectral efficiency, high data rates and high mobility, seamless coverage, diverse quality of service requirements, and fragmented user experience. This is due to each day the number of people that get access to mobile, and then they get into the mobile communication. Now, this is the proposed 5G heterogeneous wireless cellular architecture that has been given in the paper. And this claims that for 4G, what we already have in 4G is that it is to address the problem that has in 4G, that for indoor users communicating with the outdoor users, base stations, the signal have to go through buildings, walls, and many other pillars and things like that. And this causes the penetration loss. Together with that, it also damages the data rate. So that's one thing they want to cut out in our 5G network. So that's the reason why they have developed this particular architecture, which eventually has separation of indoor and outdoor. So to solve the problem, 5G architecture has been designed in a way that it separates outdoor and indoor schema, so that the penetration loss through building walls can be somehow be avoided. Now, they said this will be assisted by distributed antennas systems and massive MIMO technology. Now, MIMO technology is whereby they have multiple antennas at both the transmitter and the receiver side. So this then somehow cut down on the problem of data rate loss and the penetration. Yeah, so that's it from my side. Thank you very much.
Thank you, Jessica. Please remove your shares and exit from there, because we want Sharika to present next. She's from Latoka, and she's at the Latoka campus, and they're about to close that campus.
It's already been closed.
Okay, Sharika, go ahead.
Yes, I'm trying to share my presentation.
Yeah.
Okay.
Okay, yeah, you have shared your screen. Please
okay.
open the presentation.
Okay. Can you see it now,
No,
sir?
no, Sarika, you are not opening the presentation.
Okay.
Double click.
Double click.
Remove the check mark. Remove the check mark.
This one I'll put it down.
Hold on. Let me see if I can take control of the screen. You need.
Sarika, share the PowerPoint presentation. I mean, open the application and then share your screen.
She has to remove the check mark before that.
I have to remove the check mark. Okay, let me try again.
Click in front of your file name. There's a small tick there. Look at the folder that you have opened. For your file name, there's a tick. Remove the tick. Click on it.
I can't see.
Okay, I'm about to request remote control. Did you get any message, Sarika?
Yes, I'm clicking on approve, sir. Sam.
Okay, you've approved it?
Yes,
okay.
sir. Yes. Okay.
Hold on, don't do anything. Oh God, what is happening?
Wait, Javed, what time are you going home? Oh,
Is there anything opening at all?
Can you minimize this current, Flora?
Cannot.
Yeah, click.
Where's the share screen? Hold on.
Sir,
Hold
it's
on, hold
on.
on, hold on. Just give me a few minutes.
Okay, sir. Awesome.
Okay, Sarika, what I want you to do is close this folder.
Close the folder. Okay.
Yeah.
Yes.
Okay.
It says screen sharing has stopped as the shared window is closed.
Okay. What I want you to do is open the PowerPoint. When it opens on the screen, just tell me. Don't share anything yet. Just open the PowerPoint.
Okay. I have done that, Sam.
The PowerPoint is open on your screen?
Yes, Sam.
Okay, click on share.
Click on share. On the PowerPoint, okay.
No, on your Zoom screen. At the bottom, green, yeah.
Yes, I've done that.
And then a screen would open.
Yes.
A window would open. In that window, can you find your PowerPoint?
Yes.
And click on that.
Yes.
And then click on share or start sharing.
Okay.
Yay!
Thank you, Sam.
yay!
Okay. So, but are you able to see me all? Are you able to see me? No? Okay. Anyways, I'll just continue. Since they're about to close the room here, my activity this week, I have selected cellular architecture and key technologies for 5G wireless communication networks. The two major, as said by my friends earlier, we are moving from 2G to 3G to 4G, and now we are working towards 5G wireless communication networks. And there were two major areas of issues, challenges with 4G that the 5G is, in 5G we want to improve on. So the first one was a spectrum crisis, right? As we all know, because there's an increase in wireless devices, more and more people are connected to wireless and they use it for their personal as well as for their social life. There is a need for us to increase the potential. And another one major issue with the 4G encountered is high energy consumption. And that is when there is more energy consumption, there is more carbon dioxide release, which is affecting our green. So with 5G, we are wanting to improve on that as well. So 5G is supposed to be deployed beyond 2020. And this architecture, this article is trying to propose that we have to separate indoor and outdoor scenarios so that we can improve on 5G communication systems. And we are going to use MIMO, that is multiple input, multiple output, energy efficient communication, cognitive radio networks, and visible light communications. As you can see in the table, we have 2G, 3G, and 4G networks. 2G was introduced in 1991. First launch in the 4G was launched in 2001. And then we had 4G, which was basically for international mobile telecommunication. And as I discussed earlier on, future challenges were physical scarcity of RF. Another one was increase of carbon dioxide emissions. The expectations of 5G, as written here, 1,000 times the system capacity, 10 times the spectrum efficiency, energy efficiency, and data rate. To address the above challenges and to meet 5G system requirements, we need a dramatic change in the design of cellular architecture, MIMO, and green communication. Sorry. Okay, can see this graph. This shows there, as we move from 2011 to 2016, there's a vast increase in the use of wireless technologies. And as we move from years, there's more devices and there are more people connected to wireless. And this table also shows the internet, fixed internet, managed IP, mobile data. As we increase by years, there is increase in the use of mobile data as well. And the above mentioned trends includes including the growing number of mobile terminals and a huge increase in traffic volume generated by these devices make it necessary to implement the protocols that allow for dynamic management of mobile stations as they move between network attachment points. Okay, and this diagrams over here, this diagram over here and this slide shows smart personal networks, smart buildings, and smart city. We are moving towards these three as years go by. And these are the two references that I have used. Thank you.
Okay. Thank you, Sarika. Well done.
Okay.
Who wants to go next?
Can I go next?
Yes, Ralph.
Can you see my screen?
We can see your screen. We can see your PowerPoint. We cannot see you.
Oh, okay. Sorry. Can you see me now?
Yes, we can.
Okay, I can't see myself.
You don't have to.
Okay, so basically my presentation will be the same as the others who've presented before me. It's on the analysis of security threats and challenges of mobile technology. And I'd like you to soak on this for a second. I know it's after 7 p.m. and we're all tired. So I realized by the time I do my presentation, we would have talked about the same thing over and over again. So this is basically what Sam talked about on the first lecture about information overload. So I thought of, during my presentation, I thought of taking a different approach. I thought of, okay, if I was given 5 minutes and say if I was in the industry, how would I pitch whatever my other colleagues were talking about to management, since we are doing information management. So I thought of going along that approach. I said, okay, I'll take whatever we got and we'll try to present that to management. And I'll share. Sorry, Javed's making me laugh. So that so I'll try, like I mentioned, I'll take a different approach. So my presentation will be a bit more different than the others. So I tried think about how do I present this in layman's terms to higher management or to your managers, since we are more tech savvy people. How do we take that information that we've been presenting for the past 2 hours and present it in a nutshell to them? So and on the way, I'll share a few stories while I'm doing it. So I'd like you to read this for a moment. I guess there's this misconception that the more advanced the technology is, the more secure it is. I had a chat. I think we had a cocktail a few weeks ago with some of my colleagues who were in the industry, and they were all. I've been out of the industry for a long time. I think for 5-6 years now, and they were updating me on what's the latest goss in the networking field. So who's doing what, and etc. So like I mentioned, one of the misconception is, the managers assume that the more advanced the technology is, the better, or the more secure it is. And this is just a typical example of just this illustration is a typical example of how your managers would think. Okay, so these balloons would represent the type of applications or software that you hook your information up to, say like Javed mentioned, those Oracle, Google Drive. Like for us, what would we use personally is our Google Drives, etc. And this is how how ignorant would be. We think, okay, cloud is the latest trend, so why don't we jump onto that bandwagon? We don't realize, or we don't tend to do our research and go into deep as to, okay, what are the risks or security threats that it'll encompass. And just like how this man is hooking up his information onto the balloons and letting it float up, that's basically how we nowadays are keeping our information or storing our information as vulnerable, or as how our information is as sensitive. We just let it float. We don't realize the threats that are involved. Just a small prick with a balloon, and there goes your information. And that's some of the typical questions your managers would ask you. It's something like, okay, we try, as tech people, we try to come up with something sophisticated, to try to explain something so simple. And this is a typical example. So we try to say, something, we come up with all our technical terms. And this is what the manager would comes out. Okay, it turns out that people's biggest fear about cloud computing isn't data security. It's what happens if there is a thunderstorm. So that's what I'm trying to ask. How do you fully secure that particular information that you attached? Or what do you do? Those are the questions that we need to ask. And, we need to come up with solid, now we need to do solid research on this. And with the readings that Sam had put up on Moodle, well, I just browsed through it just a few hours ago. And here's a few things that I came across. This is with Roman Lopez and Mambo. So this is what I could gather in a nutshell. And what do you notice with this, with what they came up with? Identity and authentication, all this. These are basically what? Same threats and challenges that are faced in the internet. I mean, these are basically internet threats. Or how would you put that? How would you describe this? Basic security internet threats. So there's nothing. There's nothing different about the cloud computing. The threats that we face in the internet are the same threats we'll face on the cloud. They assume that it's in a magical place when it's hosted by physical equipment. It might have redundant backups and all, but in a nutshell, it's still physical. So people can break into it, and people can physically damage it. And those are the threats that any a property, that anybody that owns a property faces. So it's not something, like one of the cartoons mentioned, something magical. It's basically doing your research and trying to come up with measures that can easily secure your information. Yeah, so basically that's it. And I'm, how many more minutes left? Okay. Yeah, so basically, yeah, I'd like to end with this slide. Thanks. Thank you.
Thank you, Ralph. Yeah, thank you for entertaining us. Who wants to go next?
Can I go next?
Aisha, you can go next.
Thank you. Ralph, can you please unshare the screen?
Is that okay?
Yeah. Are you able to see my PowerPoint slide?
The slide, Aisha, but we cannot see you.
Okay, hold on.
And we can see you now.
Okay.
Go ahead. Thank you.
Set. Hi, I'm Aisha. I'm going to talk about network management and mobility in this session. Oops, sorry. I'll start by actually defining what is a network. A network is a connection of network devices that transmit signals between the sender and the receiver, basically the source and the destination. There's three types of network computing infrastructures: intranet, extranet, and edge. I believe everybody should now be able to understand what intranet and extranet is. And as for edge, let's see what edge is. Edge computing / network can be used together. It's a practice that allows data produced by the Internet of Things. Basically, I'm saying whatever the other colleagues have already said. Devices to be processed closer to where it is created instead of sending it across the long routes to data centers or clouds. This is the diagram that I got from one of the reading materials posted on the Moodle. It shows where the edge network actually lies around. I'm sorry, I'm a bit under weather, so I won't be able to, my voice is not that good. This is what edge computing is. Now, for edge computing, there was three different paradigms for edge computing. One was fog computing. In fog computing, it is decentralized computing infrastructure in which data, compute storage, and applications were distributed in the most logical, efficient place between the data source and the cloud. For the mobile edge computing, it is a network architecture that enables IT and the cloud computing capabilities at the edge of the cellular network. So basically, this was about the network, mobile network. Then there was mobile cloud computing. Mobile cloud computing uses cloud computing to deliver applications to mobile devices. These mobile apps can be deployed remotely using speed and flexibility and development of tools. As Ralph has already said, there were some challenges and benefits of these edge paradigms. Benefits were low latency, high bandwidth access to radio network information, and location awareness. Challenges were still security, the man in the middle, the denial of services, the basic security that we have already seen in other slides. Now, the question, what is network mobility? The definition that I got was the network mobility is the mobility of the entire network that changes its point of attachment to the internet as a single unit. Basically, as you move through, you will be able to have the same level of connectivity. That's what I got from the term network mobility. What is network management? Actually, this is a very important part of any network administrator. Network management includes the deployment, integration and coordination of the hardware, software, and human elements to monitor, test, poll, configure, analyze, evaluate, and control the network and element resources to meet the real-time operational performance and the quality of service requirement at the reasonable cost. The reason why we have to manage a network, because network plays a role of ensuring service reliability. By design, the internet ensures a good blend of performance and economy by allowing multiple users and applications to access the same pool of bandwidth, but there is also a pool of latency that has been allocated according to the application need. A good network management is now more important than ever, both for keeping things running smoothly and getting more value out of the network infrastructure. That's it. Sorry, I had to like really fast track the.
That was good.
Thank you.
Thank you.
Next.
Wait, hold on, I'll stop sharing.
Where is the one, two, one?
Sir,
We have 5 students.
ITS room, yeah.
we got
5
5
students.
students left, and it's already 10 past 7 here. So should we continue?
Yes, please continue if you want 2.5%. And the rest that are present,
Who's next?
and the rest that are presented, it is after 7 p.m. In fact, your classes are supposed to be from 5 p.m. to 8 p.m. So those that are presented and need to go, you can disconnect. Those that have not presented and would like to have 2.5%, please present.
Thank you.
Really.
Say, hello.
Yes, go ahead, please. I can hear you. I cannot see anything. I cannot see you. I cannot see your presentation. ICT conference room.
Yeah, we're here.
Okay. You have started sharing your screen. I can see your PowerPoint presentation. Mandeep, I cannot see you.
Video start करो.
It's down here, Mandeep. Down here. Down bottom right hand side. Or just press F5. Oh my God. It's like a movie.
Okay, good evening, everyone.
And where's the hero of the movie? I cannot see the hero.
Hero is
Say it
typing on
disappears
the.
if we have a slideshow like this. I think.
Yeah, you can show yourself as well, Mandeep. All you've got to do is click on start video. Can someone in the ITS lab help him? ICT conference room help him? Show video? Or someone switched off the video camera? Okay, Mandeep, go ahead. Talk about your presentation. Let's get it over with.
Okay, say so. Few of the colleagues have already talked about this. Cellular architecture and key technologies for 5G wireless communication networks. Everyone knows what is network, what is mobility, what is wireless network communications 5G to be implemented by 2020. The article that I've chosen was named as Cellular Architecture and Key Technologies for 5G Wireless Communication Networks. And it talks a little about the importance of ICT. All of us are aware about the importance of ICT. It's taking our lives it's like impacting our lives in a huge manner. And then the development of wireless technology, there are some challenges to it. To name a few, physical scarcity of radio frequency spectrum allocated for cellular communications. As there are more users, they need more bandwidth. There is high energy consumption causing an increase in carbon dioxide emission. It's harmful for the environment. There is high data rate, and data rate is referring to the speed at which data is transferred, and then fragment user experience. That means there's incompatibility with the different wireless devices. And as a solution, as stated in the article, to have a potential 5G wireless cellular architecture, and the key technologies to be implemented with this 5G wireless cellular architecture, one of them has been talked about is massive MIMO. That's massive input, massive output. I have a small video here. Hopefully we can view the video.
Mandeep, a video in video. We cannot see any video.
Hold on.
We can see you now. So your video needs to be played on your computer screen.
Still loading, sir.
Okay, no problem.
So I think it's taking a lot of time, so I just continue. In case if it gets loaded, then I'll show you the video.
Forget about the video, just send me the link to everyone else.
Okay, so that's about massive MIMO has been talked about, where multiple antennas were being used to allow for more information and data to have reliable and energy efficient communication. Also had spatial modulation, again using multiple antennas, and cognitive radio networks. The future challenges with wireless communication networks. The first one, optimizing performance metrics. More performance metrics should be considered for a fair and complete assessment, that is spectral efficiency, energy efficiency, and reliability. There's something known as complexity of signal processing in MIMO, so we have to reduce signal processing complexity for massive MIMO. The transmitter and the receiver, the signals are quite lengthy. Hence, the search algorithms must be performed over many possible permutations of symbols. And then we have interference management. To counter these, there needs to be some techniques to apply to cancel the interference from cognitive radio networks. The evolution from 1G to 5G networks. 1G was designed for analog communication, introduced in 1980s. Then we went to 2G, which allowed for phone conversations. and the conversations were digitally encrypted. Introduction of data services for mobile, which was SMS, as you can see in the diagram. For 3G, it allowed for faster internet speed, wireless voice telephoning, mobile internet access, video calls, and mobile TV. Coming down to 4G, amended mobile web access, allowed for gaming services, high definition mobile TV, video conferencing, and 3D television. And as I mentioned earlier, there were still problems with 4G networks. That's why they are trying to implement 5G networks, which we'll come to know about in hopefully in 2020. The table there summarizing the networks from 1G to 5G. As we can see, from 1G to 5G, the data bandwidth has increased significantly together with the service, providing a wider range of service compared from 1G to 5G. The challenges in next generation communication and the applications, virtual presence. This means that 4G and 5G provide user services at all times, even if the user is off the site. Telemedicine, 4G and 5G will support remote health monitoring of patients. Telegeoprocessing, combination of geographical information systems and GPS, in which a user can get the location by querying. Crisis management, natural disasters can cause breakdown in communication systems. And then 5G is expected to restore such crisis issues in a few hours. For education, for people who are interested in lifelong education, 5G has to provide a good opportunity. Anywhere in the world, people can continue their education through online in a cost-effective manner, like what we are experiencing now. Say you are there in Malaysia and we are here. And artificial intelligence, more applications combined with AI, as human life will be surrounded by artificial sensors, which could be communicating with mobile phones, traveling, security, and economic growth. And that's it, sir.
Thank you, Mandeep. Very well done. We'll see the video later. Who's next? Rajneet, are you still there? Do you want to present? Rajneet?
Yeah, I can go ahead.
Okay.
Give me a second. Can see my presentation?
Yes.
We can see your presentation, Rajneet. We cannot see you.
Just give me a second.
We can see you now, Rajneet. Go ahead, please.
Thank you. Okay, so my presentation is on wireless virtualization. What is wireless virtualization? This is virtualization that is extended from wired to wireless network. The virtualization of wireless network, wired networks and computing systems has become a leading trend in nowadays ICT systems. But however, very little has been done in regards to virtualization in infrastructure-based wireless network. But the idea of virtualizing wireless access is gaining attention as it has a potential to improve spectrum utilization and perhaps create new services. It also improves efficiency, utilization, and enables customized service and multi-tenancy. Wireless network virtualization includes both infrastructure sharing and the spectrum sharing as well. Major wireless domains such as Wi-Fi, cellular network, wireless application in IoT have been linked with new architecture involving virtualization.
benefits. The motivation behind this wireless virtualization follows from the observed benefits that we have seen in wired network. That is the ability to embed virtual networks on physical infrastructure. Benefits such as commercial, in terms of commercial markets, include the capital expenditure and operating expenditure, which can be reduced due to sharing of resources. Network slicing, this basically is like when a company, a service provider, or a mobile network operator wants to do some upgrading or maintenance work, they'll be able to divide up the network and upgrade a particular part of it, and not avoid disruption, network disruption for customers, as there'll be services still available for them to utilize. Quality of services also enhanced for the service providers with more customized and flexible services, as service providers are leasing virtual networks from the mobile virtual network operators. Some challenges that are on the next slide are interfacing. This is basically in wireless virtualization. Service providers require radio services such as bandwidth, power interference from one or more infrastructure providers. Since various radio access technologies might be used by service providers on the same infrastructure, a well-defined common interface is a must for the infrastructure providers to understand the radio resources required by the service providers. Resource allocation and resource discovery in wireless virtualization. In wireless virtualization, constraints such as finite radio resources, service providers' quality of service requirements, and different infrastructure providers' policies need to be included in this problem. In order to allocate resources to service providers, the infrastructure providers should be aware of the available radio resources of wireless network and coordinate among themselves, and which should be done in advance before each infrastructure provider assigns his resources to the service providers. Infrastructure providers may need to reserve some resources for themselves in such cases, in which cases the infrastructure providers need to determine what radio resources to keep and how much they are willing to share. There's also mobile mobility management. Mobile users should be able to smoothly switch to their contracted service provider or a preferred service provider, or even a better scenario would be like users should be able to, users might access any service provider, either offering the best quality of service or lowest cost in terms of geographic locations. And in the next slide, I'll just discuss some projects in wireless virtualization. The first one is the global environment for network innovations. The goal for GNI is to enhance experimental research in computer networking and distributed system, and to accelerate the transition of research into products and services that will improve economic competitiveness of United States. The concept is being explored by United States Computing Committee with support of the National Science Foundation. The second one is the smart application on virtual infrastructure. The main research goal of SAVI network is to address the design of future application platform built on flexible, versatile, and evolvable infrastructure that can readily deploy, maintain, and retire large-scale, possibly short-lived distributed applications that will typically in the future applications marketplace. That will be typical in the future applications marketplace. This project is headed by the Canadian industry and their academia, research, and education networks. And next is my references. Thank you.
Thank you, Rajneet. Who wants to go next? Rajneet, you need to stop sharing your, yeah. I can see you. Oh, Rosarina, is that you? Good to see you.
Hello, can you hear me?
Speak a bit louder, please.
Hello, can you hear me now?
Yes, I can hear you loud and clear. Can you hear me?
Yes, I can hear you loud and clear too, thanks.
Okay, Rosarina, thank you for coming today and gracing my course. It's an honor to see you.
I'm very glad to be part of this course. I actually am interested in the whole thing, so happy to be here.
Thank you. Please proceed.
Okay, so good afternoon, everyone. I think my other colleagues here have also presented on the 5G wireless communication network. So hopefully what I can bring with my presentation is hopefully something new that that we can all learn from. Basically, why I chose this 5G wireless communication network was when I thought about it, I didn't know much about 5G. I mean, we all know that yes, it's faster data, more uptime, but other than that, that was all that I knew. So I went into it. So before I went into this, I wanted to know exactly why we needed to move to 5G and not stay with 4G. So basically, I decided to highlight the challenges, which some of our other colleagues have highlighted. And one was the customer demand. Basically, customer demand, everyone wants faster internet, and everyone wants instant communication, whether they're on a train, whether they're in a conference room, they want it instantly. And I mean, everybody has more than one device. For example, one person can have a phone, an iPad, and a laptop all connected to the internet. So the demand to be online has increased substantially that I don't think that they realized that it would increase this fast. The second challenge that I thought was very significant was the energy consumption. I think in one of the journals that you put there, the energy consumption, energy efficiency wasn't even considered as an initial requirement for 4G equipment when they started building that. Only when the increase in the demand came, and so they had to bring in advanced wireless technologies to cater for this 4G, did they realize that the amount of energy being consumed created more O2 into the environment. So this leaves more of a carbon footprint, which I think now we're all trying to steer into a more environmentally friendly area. The third one that I wanted to talk about was the penetration loss. I think Jessica mentioned the penetration loss within indoors. So as she did mention, indoors, basically, when you try to access your mobile data inside, it hits the walls, your data is lost, part of it is lost. Maybe you might not get the full message through, or it might be delayed. So these were some of the challenges, or is some of the challenges that we still face with 4G. And the other one was the scarcity of the radio frequency. The radio frequency, basically, they have a band which they call the UHF. And it's a range from megahertz to gigahertz. But in all of that, we've almost utilized most of it. So when they try to look for more bandwidth to use, unfortunately now the operators find it difficult to allow for more space on that UHF band. So basically, these were the challenges that I thought that I should highlight for 4G, and that were important why we should move to 5G. So for the next slide, the first one was massive MIMO systems. Basically, as highlighted earlier with my other colleagues, This is just numerous large antennas at base stations that transmit and receive to serve large number of users simultaneously. Sometimes I think we experience this. I've had it a few times with some of the gang at work when we're all in a Viber group, and some people get the messages at different times. So when I read this is how I understood that this massive MIMO would assist if we had to move to 5G. I wouldn't have to say, oh, just because I'm on a different network, it's going to be slower. Everyone should get it at the same time. The other one, the second point for potential 5G was that cellular architecture, as also highlighted by my colleagues. This was separating indoor and outdoor scenarios to avoid that penetration loss, which I highlighted in the top as one of the challenges in the 4G network. The other one, which was visible light communication, VLC. This one was very new to me, so I wanted to know what it was, and it's actually white light emitting diodes, which is white LEDs, signal transmitters. So what they basically do is when they illuminate, they provide that broadband connection. So it's actually your data is being transferred onto a light emission and being communicated to whoever you send in messages to or receiving messages from. So I thought that was pretty cool, that VLC. The other one was green communications. As I said earlier, we're in this state where we want to be environmentally friendly. So 5G is looking at their wireless equipment to be more, to have less of a carbon footprint. So I thought that was very important to note that if we move to 5G, we will be environmentally friendly here. So I went on to find out more about the 5G architecture. Then I realized that when you actually do have 5G architecture, it's, the way that they divided it was into enhanced mobile broadband. It's not too clear on that slide. I think the lighting or something, but sorry. Okay, so how the 5G architecture is you have, it's divided into enhanced mobile broadband, and then there's the second one on the bottom left, which is massive machine type communications, and on the bottom right is the ultra reliable low latency communication. So basically, if we had to be on the 5G network and you have to send something on the network, it would divide your data in this way. So for the enhanced mobile broadband, basically you're looking at applications and services that require increasingly fast connections, like watching stream video, or if we had to look into the future technologies, streaming virtual reality. I wish I can see that too, streaming virtual reality. Yeah? The second one, which is the massive machine type communication, someone mentioned in their presentation about smart cities. So this is basically it, where like a community or an area is encompassed with all like Internet of Things, and they require less broadband coverage, low energy consumption, and a slower transmission. So this is basically like the example when it was mentioned, I was like, okay, so this is where that would go into for smart cities, massive machine type communication. The third one, which was ultra reliable and low latency communication, this one I thought was a very crucial one, because an example here of where you would use this, it had to be extremely reactive, strong message guarantees. So in the sense, I thought of in a scenario where you could use this. We did a project, I think it was last year, on virtual surgeries, where in the medical history, I mean, well, now that they've advanced, surgeons can be in a totally different room or a totally different city and conduct surgeries on someone who's totally somewhere else based on these wireless technologies. So in this sense, you would need that ultra reliable, low latency communication, because every single thing matters. If there's a latency, that could mean death for the patient on the bed right there. So I really like that URLLC. So that was the 5G architecture, and well, I thought to highlight the comparison, but then I also saw that a lot of my colleagues here also did comparison. So I think everyone's very familiar with the difference from 4G to 5G. So I hope that was very informative for everyone. Thank you.
Well, indeed, very well done.
Thank you.
Thank you, Rosarina. I mean, yes, this is why I do this type of teaching, or I have this element within my courses. If you have, for example, Rosarina, if you have learned nothing from this course, from this session, you will definitely remember about 5G. So at
Yes.
least you get to learn one of the things or something from the course. Okay, who's next?
I'm next, sir.
And you are Asaili?
Yes, that's right. Good evening, everyone. And my topic of discussion this afternoon is on wireless virtualization and its users. I promise to keep my presentation short. I think everybody wants to go home. And come again? I'm Asaili. Yes. Okay, my presentation today will talk on what wireless virtualization is, the advantages that it brings, and the uses or the applications whereby we can use wireless virtualization. Firstly, virtualization is something that is not, now has not only been kept to the physical wired network, but it has extended to the wireless network. With wired network, as it explained, it has the devices have to be physically connected. Unlike in the wireless network, the communication has to be done through a electromagnetic wave that has no visible boundaries. Also, virtualization in the virtual wireless scenario, virtualization is done on the network interface and the access point. For example, in a cellular network, shown here, the infrastructure is decoupled from the services it provides, so the differentiated services can share the same infrastructure, maximizing its full utilization. As you can see, the physical network is there. It is virtually sliced into virtual networks, which can be, which are further, which helps in the scenario of this virtual network. Advantages of a virtualized wireless virtualization: there's a significant reduction in capital and operational expenditure, as I have shown that there is no need to buy a physical inventory, or we can virtualize a machine and use it for your network. Another advantage is when we do servicing or upgrade, it will not affect the other services if one of the sliced network is worked on. This also with wireless virtualization attracts wider and a larger reach of customers, which is ideal for some of the suggested urban cities that we have. My colleagues have.
Can you hear me?
Yes.
You have not opened your PowerPoint slide.
Oh. Sorry. Resume. Can you see now, Mr.?
No, still cannot. Close this and probably share it again.
New share. Yeah.
Yeah, we can see it now. Thank you.
Those are the mentioned advantages of wireless virtualization. The use of wireless virtualization, I believe virtual virtualization is one of the key technologies that would support the 5G scenarios or technologies which have been discussed, namely mobile cellular networks with wireless virtualizations. There is a wider reach and coverage for mobile users with a better service. Another one is the Internet of Things. With wireless virtualization, it gives the platform and the resource that it needs to fully realize its full potential. And that's my presentation today, and these are my references.
Thank you, Asali. Who's still left to present?
All done, sir.
All done?
Yes.
Oh, that's good. Thank you, everyone, and thank you for staying back. I mean, we have almost hit the 3-hour mark. Any questions or comments before we call it a
Sir,
night?
the proposal.
Yeah.
We got 2 questions. First, as you have mentioned, we have to select 10 articles for the proposal. So, in order to select the 10, we need some time. And
Okay. So I knew it that even whenever the students are given an extension, they will jump for it. But I'm going to do it on a case-by-case basis. So you can see that a number of people have not, or a number of students have not attended today's lecture. So what I'm going to do is I'm going to grant an extension on a case-by-case basis. You send me an email saying that you want an extension, and until when, it cannot go beyond Friday the 24th. It cannot go beyond Friday the 24th because that's when the break is. So you send me an email with your postcode and